Hi and hello, myself Santhosh Kumar. I am a physics faculty. I have 11 years experience with a different kind of institutions. Right? Today we are going to discuss about the oscillations. It is one of the beautiful topic in a plus one. Right? So generally we can observe at least two questions in a NEET and at least one question in a JEE. So this is the very important chapter for the JEE as well as NEET. So that's why we are going to discuss oscillations today. See, now what is oscillations? Actually, we know the different kind of motions in a mechanics. So generally, so we can observe a linear motion or curved motions. So oscillation is also one of the type of motion. So we can understand. So we can discuss briefly within this chapter. For example, a simple harmonic motion or oscillatory motion and damped oscillations. So like that motions we are explained within the oscillation, right? Okay. So now we are entering into the topic. First part. So if you are discussing about the oscillation, first we need to know the basic motions. So which is going towards the oscillations. What are those? First one is periodic motion. What is periodic motion? If you observe the examples, the first example, so we are taking first example is uniform circular motion. So and next second example is orbital. So orbital motion of the planets in the solar system. And next example we are taking so motion of the simple pendulum. And next so vibrations of the string in a guitar. So these are the example we are observing. In every example, the first example, here the particle is moving around, so along the circumference of the circle with a constant speed. Okay, with a constant speed, it is moving continuously. Now, within this case, the path of the particle is repeating every fixed interval of time. Okay, so every fixed interval of time, the path of the object is repeating. And in the same way, here also, so planet is revolving around the sun. So here also, the path of the planet is repeating every regular interval of time. For example, if I am taking, so Earth is revolving around the sun. So and the path of the Earth is repeated after every 365 days. That is nothing but 1 year. Okay. So every 1 year or every 365 days, the path is repeating in this case. And if you are observing about the simple pendulum, so the simple pendulum path is also repeating every fixed interval of time. And the same way, the vibrations, so vibrations of the string in guitar, so the vibration, so a string is also repeating its path continuously, so after fixed interval of time. Now what we observed in every example, the time period of your objects is constant, and next one, the path of the object is repeating so continuously. Now such type of motions are called so periodic motion. So periodic motion is nothing but the time period of the object is constant and the path is repeating continuously. Such type of motions are called so periodic motion. See, so what is the definition for the periodic motion? So the scientific definition for the periodic motion, the motion which represent at regular interval of time, so is called as a periodic. So periodic motion, the motion which repeats so at regular interval of time. So the motion which repeats in regular interval of time is called as a periodic motion. Now the path is repeating regularly. So in this case, whatever the example we observed, in all the example the path is repeating in a fixed interval of time. So that is your so periodic motion. Okay, so understand periodic motion. So periodic motion is nothing but if the path of the object is repeating in a regular interval of time, such type of motion is called as a so periodic motion, right? Okay, now when we are observed the special cases, these two examples, when you are observing these two examples, so these two examples are different with the previous two examples. Okay, now there are some specialty with the comparison of the previous two. What is the specialty? Now the path is so within this case the path is repeating so continuously in this case. So it's a continuous manner. But in this case, the path is repeating so with the help of to and fro situation. So with the help of to and fro situation, in the strings also, the guitar strings also making to and fro motion. So in that manner, the path is repeating. Okay. So these two is a special kind of motion within the periodic motion. So these are also periodic motion, but so we have one speciality within these two, that is to and fro motion. So to and fro motion, with the help of to and fro, it's repeating its path. But the previous examples, it's repeating its path continuously. Now that way, these two we are calling as a oscillatory motion. So what is oscillatory motion? So oscillatory motion is nothing but if a motion is following the periodic motion condition, as well as it is also showing a special condition, so to and fro condition. So then it is called as a oscillatory motion, right? Now we are observing about the oscillatory motion. What is oscillatory motion? See this example. So motion of simple pendulum. The pendulum is repeating its path in regular interval of time with the help of to and fro, to and fro, to and fro. So about a fixed position. And the same way, so within the swinging pendulum in a clock. So within the clock, now this pendulum is repeating its path with the help of to and fro. Okay. So this is your example for this specially oscillatory motion. Now what is the definition for oscillatory motion? So oscillatory motion is nothing but it's a periodic motion. So generally it is a periodic motion. Within the periodic motion, if object is repeating its path with the help of to and fro, so that is called as a oscillatory motion. Okay. So oscillatory motion. So the periodic motion which a body moves to and fro about a fixed point is called oscillatory motion. Okay. So to and fro motion about a fixed point is called as a oscillatory motion. Right. Okay. Now, so we said just now, so periodic motion, so oscillatory motion is nothing but periodic motion only. So we have any condition between periodic and oscillatory motion? Yes, we have one condition. A note. So all the periodic motion need not to be oscillatory motion, but all oscillatory motion, it should be periodic motion. Okay. So every oscillatory motion is a periodic motion. Always it's a periodic motion. But every periodic motion is not an oscillatory motion. Okay. Every periodic motion, it's not an oscillatory motion. But every oscillatory motion is a periodic motion. But this condition is always true only when there is no energy loss is presented within the oscillator. Okay. If energy loss is presented, then this condition is not valid for such type of cases. For example, how we can explain that sentence. See, for example, if I am taking the simple pendulum motion, if I am explaining about the simple pendulum motion. Now, so this is, for example, this is your one of the simple pendulum. If I am giving some energy for this one and it's oscillating like this continuously. Okay, so it is oscillating like this continuously. If it is oscillating continuously, so due to the air resistance, what happened after certain situation, the length of the path is decreases continuously and it's going to stop. That means, so the energy of the oscillator is decreasing in this case. So due to the decreasing of energy, the complete path is not repeated in this case. So the complete path is not repeated. If complete path is not repeating, then it's violating the periodic motion condition. Periodic motion is always says if object is completely repeating its path within the fixed interval of time, then only we can call it as periodic motion. But in this case, the energy of oscillator is decreasing. So due to decreasing of energy of oscillator, what happened? The path length is decreases continuously. So this type of motion is called as a damped oscillations, but it's not a oscillatory motion. It's never be oscillatory motion. Why? Because complete path is not repeating in this case. Okay, so that's the way. So we are giving the one sentence in this case. So every oscillatory motion is a periodic motion. Every oscillatory motion is a periodic motion only when there is no energy loss is presented. Otherwise, it's not follow that condition. Okay, right. Next one. So next one, a general oscillatory force equation. So generally if object is moving in this case, object is making the motion in this case, that means one of the force is working on the object. So we have to write out the force equation for the moving object in this case. So here it is oscillatory motion. So we have to write out the general force equation for the oscillatory motion. So general oscillatory force equation is F is equals to minus k x to the power of n in this case. So F is equals to minus k x to the power of n, where n is equals to n is equals to 1, 3, 5 and so on. Why we are taking only odd numbers in this case? So and why we are taking x? Okay, so we have to explain about the first. So why we are taking only odd numbers, and next one we have to explain why we are taking minus in this case for the force. So equation is F is equals to minus k x to the power of n, where n is equals to 1, 3, 5 and so on. We are taking only odd numbers. We have to explain about the why we are taking odd numbers in this case, and we are taking minus in the force equation. So why we are taking force minus for the force. Okay, these two conditions we have to explain. And first, so what is the F in this case? F is force, and next k is constant, and x is displacement of the particle. So in this case, and one more condition we have to explain, which is the reference position. So for taking the displacement, we have to observe the reference position for taking of displacement. So these are the three situations we have to explain in the case of general oscillating force equation. So first one is why we are taking minus, and why we are taking only odd numbers, and next one why we are taking the which is the reference position for your displacement. Okay, first we are explaining about the reference position of the particle. That means displacement position. So reference position for the displacement in this case. So if we put x equals to 0 in this equation, so what is the, so if we put x equals to 0 in this case, then what happened to force equation? Force equals to 0 ultimately. So force is 0. So that means at x equals to 0, force is 0. Where the force on the object is 0, that position we have to take the reference position for our oscillatory motion. Okay. So the reference position is at force is 0. At which position force is 0? At which position force is 0? That position we have to take as a reference position for your oscillatory motion. Okay. So that condition we are getting with the with the putting of x equals to 0 in this case. If x equals to 0, then force is 0. This force 0 position we have to take as a reference position for our oscillatory motion. Okay, so from that reference position only we have to find out our displacement of the particle. Okay, next one. So then so in the above equation, x is considered as, consider from where force is 0. Okay, so the x is considered from where the force is 0. That is your condition in this case. And next one, so now why we are taking minus in this case? So in a force equation we got the minus. Why we are taking minus in this case, and we have to explain why we are taking odd numbers in this case. The first one, and then we are explaining about the odd number as well as minus at a time. See, if I am taking the x is positive, for example x is positive. If x is positive, and what about the force in this case? If x is positive, ultimately your force is F is equals to, so x is positive, so and minus k x to the power of n. You are getting the negative force in this case. So negative force. So in a coordinate system, the negative force indicates towards the negative x-axis. I am indicating like this. This is your negative x-axis direction. So if x is positive, your force is negative. And if I am taking the even number, if I am taking x is negative. So if x is negative, then what happened to your force equation in this case? So the force F is equal to minus k x to the power of n if x is negative. If I am taking odd numbers, then minus x to the power of 1, then ultimately you will get the minus, so the power is 1, then ultimately you will get the minus x only, x to the power of minus x to the power of, right. If I am taking x is negative in this case, x is negative, so see, x is negative, if I am taking x is negative, what happened your force equation? Is it positive force or negative force? We have to observe. For x is negative, minus, if I am taking x n equals to 1, so odd number. Why we are taking odd number? Here only we are observing in this case, if x is negative, minus x to the power of 1. So then it's a minus x, minus and minus, this minus becomes as a plus, then force becomes as a positive. So the force becomes as a positive, then it works towards this direction. The force is working towards this direction. If I am taking x is positive, the force is in this direction. If I am taking x is negative, the force is in this direction. So otherwise, if I am taking even number in this case, for example, x is negative minus x to the power of 2, then it becomes as a positive x square, positive x square, then force becomes as a still negative only. So force becomes as a still negative. That means your force is working in this direction. If force is working in this direction, object is not going to repeat its path. Why? Because here the force is working towards the negative direction, then particle is moving towards this direction due to influence of this force, and it's coming like this in this direction. After getting this position, the force, so your x is negative, and we are taking x, so n power n is 2, it's an even number, and due to that even number, force again becomes as a negative only, and it's still your force is working in this direction, and path is moving in a linear path continuously, so in this direction. So that is not an oscillatory motion. So oscillatory motion, it always shows that path should be repeated. So that's why, so to indicate that situation, we are taking only even numbers in this case to get the negative. So to change the force direction always, so we are taking only odd numbers in this case, only odd numbers, and we are taking minus in this case. Okay, that is the reason we are taking odd numbers, powers, as well as minus in the equation. Okay, right? So we are observing, in case of x is positive, your force is negative, it's working in this direction. In case of x, so it's negative, your x is negative, your force is positive, it's working in this direction. If particle is trying to move in this direction, so it's particle, if it is trying to move in this direction, your force is pulling in this direction. If particle is trying to move in this direction, your force is pulling in this direction. That means every time your force is trying to pull the object towards the one fixed position, that position, your reference position, that we are calling as a mean position of your path. So every time your object, so whatever the force is working on your object, it's always try to bring the particle or object at mean position. So simply we can understand in this case, we know generally, so three types of equilibriums. What are the three types of equilibriums? The first one is stable equilibrium, and second one is, so what is the second one? So unstable equilibrium, and third one is neutral equilibrium. So every object trying to get the stable equilibrium only. Why? Because it's more stable, and potential energy of the object becomes as a minimum in this case, and it's more stable position. So unstable equation, so it's a unstable situation. The force, ultimately force is 0, but object is not stable in that position. So in this case, if you are observing this type of oscillatory motion, the force is trying to pull the object towards the mean position. When it is coming at the mean position, what happened? The force, the previously we observed, at mean position the force is 0. So force is 0. So that means object is trying to get the stable position. The mean position is the more stable position. Why? Because the force is 0 at the position, and potential energy is minimum in this position. So that's why object is trying to get the stable equilibrium position. That position is only the mean position. So that's why always trying to come towards the mean position. Object is always trying to come towards the mean position. So we can understand from this situation. We simply concluded that your oscillatory motion is an illustration of the stable equilibrium only. So it's a stable equilibrium illustration only. So always object trying to get the mean position, that is stable equilibrium position. So that's nothing but, your oscillatory motion is a stable equilibrium illustration only. So that's why, we are discussing that situation in this case. Now we can write one note in this case. Here the force is always trying to pull the object towards the mean position, that indicates stable equilibrium position. This is your stable equilibrium position. And simply we can call it as a, so oscillatory motion is an illustration of the stable equilibrium only. Okay, right? So understand. So why we are taking minus and why we are taking even powers and why we are taking, so which position we are taking, the reference position. So that is your explanation about this topic. Okay, next. So next, if you are going about a special kind of motion in the oscillatory, that is your simple harmonic motion. Okay, so very important topic in oscillations, that is simple harmonic motion. So simple harmonic motion. See, in the previously we observed the powers of x 1, 3, 5. If I am taking x power is n equals to 1, if power is n equals to 1, then the force equation becomes as a, so if n equals to 1, so the special case in oscillator motion, the special case